Now we have to understand the stress as we were talking about the deforming forces. So whenever we apply deforming force, then what happens? We know that intermolecular distance changes, and because of that, internal forces, restoring forces, are developed opposing that outside change, which is due to the forces applied on the body. So these restoring forces per unit cross-section area of the body is called the stress. These restoring forces, not cross-section area, just per unit area of the body, is called stress. So stress is basically force per unit area. So stress that we are defining is force per unit area. That means its unit will be same as that of the pressure, which is Newton per meter square, or you can say the Pascal also. So this is stress. So stress is basically a result of application of deforming forces. And stress is defined for internal restoring forces only, not because of the external force. For example, suppose here we have got a rod and we apply pulling force on both the ends of the rod. Then suppose visualize the one part of the rod here just by cutting it mentally, and this is the another part. So here F force is there as shown here, and this part is also experiencing the force F. As we know that in whole rod net force is 0, so it is not going to move anywhere. So the part of the rods also must be having net force 0. Suppose here we have got force F dash, then it must be having F dash according to the Newton's third law, and according to the requirement of the equilibrium, this F dash must be equal to F in this case, which is not true, may not be true in some other situation when the whole system is suppose accelerating. That case net force will be there, but for now since net force is 0, so F it becomes equal to F dash. So F dash is the internal force appearing inside the rod because of the application of the external force. In this particular example, this force is by chance equal to this applied force, but it is not always true. So that is why I am telling you repeatedly that stress is always defined for the restoring force which is developed internally. And depending on the type of the loading that the object is being subjected to, there are three types of stress. First one is the longitudinal or the normal stress. So in case of longitudinal, the normal stress, we apply the force along the length. That means it is basically one-dimensional force. The force is applied along a particular line, and because of that, the stress may be tensile or compressive. For example, here is a rod and we apply force on both ends F in opposite directions. So it is the situation of tensile stress, because such kind of force have got a tendency to increase the length of the rod. But in this case, the force is applied at both ends in such a way that they are trying to reduce the length of this rod. So this is compressive stress, but both ways it is longitudinal stress or the normal stress also, because this particular force is perpendicular to the area on which the stress is calculated. That is why it is also known as the normal stress. Alright. So longitudinal stress or the normal stress can be of two types. One is tensile stress, the other one is the compressive stress. And suppose F is the internal force of tension or the compression generated inside the rod, then this longitudinal stress is basically force applied divided by cross-sectional area. F is here what? Internal force that is being developed because of the external forces. So this is longitudinal stress. The second situation is the tangential stress. For example, if we have, suppose there is a cube like that, and if we fix the lower face of the cube on some surface and apply a force on this cube parallel to its surface, then what will be action of this force? This particular force will try to distort this cube like that in its own direction. It will try to distort the shape by turning it by a certain angle, both the faces of this cube. So this is basically shear stress, the tangential stress. For example, if we take the same thing but this time if we say that some force at this point is applied at a certain angle, say F, and this is basically fixed at the lower end, then we can find the two component of this applied force. One is the tangential component and the other one is the normal component of force. So normal component of force divided by this area, it is what? Normal stress or the longitudinal stress that we learned in the previous slide. But here this component will give rise to tangential stress or the shear stress. So when the force is applied parallel to the surface, then it generates a shear stress, and its effect is to produce distortion or change in size. If you just visualize the example of a balcony which is being projected out from a building, then you can understand that here, if we just consider some portion of this balcony, then for this portion its weight is acting. So this portion of the balcony must be applying some force in this direction to hold on the weight of this particular portion. That means you can see that here you can feel the tangential kind of a stress, and here there is a normal stress also, but you can clearly see the tangential stress also. So tangential stress is basically the force parallel to the surface divided by that area. And the third type of loading is basically bulk stress, or all around stress or pressure. Basically, just consider a situation. Suppose here we have got a vessel and it is completely filled with water, suppose, and here it is some object inside the water. As we know that in case of water, the molecules will apply force on this object from all possible directions in 3D. In fact, it is a spherical body, then forces are coming from all over directions, but the force is applied on all the points of the surface of the body and normal to it. That is the situation. Here the force is basically applied on the over the volume. For example, you are trying to squeeze a ball in by grabbing it within your palm. So when force is acting all along the surface normal to the area, then force acting per unit area is defined as pressure, and that pressure is basically the bulk stress. Okay, suppose here it is atmospheric pressure everywhere. So atmospheric pressure always apply bulk stress on different objects, because all air molecules will be hitting all objects from all possible directions. Okay, so this particular situation is for the bulk stress. So change in pressure or the pressure, basically it is known as the bulk stress. So whenever bulk stress is referred, then you can understand that we are talking about the change in pressure or the original pressure of the system. So bulk stress is what? Change in pressure.